Okay, in this video, we are going to talk about some sort of strange trig sum and difference formula problems. So they're not going to be like the typical, or they're not going to start out looking like typical problems. So you're probably familiar, hopefully, with the sum and difference formulas. And they look like, you have sine of x plus y is sine x cosine y plus cosine x sine y. You have sine of x minus y is sine x cosine y minus cosine x sine y. And then we have cosine of x plus y, and we have cosine of x minus y. So when you look at those formulas, you see like patterns that develop, right? So you have a sine of x, a cosine of y, and then a cosine of x, a sine of y. So you have sine, cosine, cosine, sine. And then for the cosine formulas, you have cosine, cosine, sine, sine. But what would we do with something that has this? So it's sine, sine plus sine, sine. So we need to try to figure out what to do with this sort of thing. Or maybe you'll see one that has cosine, 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 cosine. So these aren't looking exactly like the sum and difference formulas. And these will only work if they're selected really carefully, but if I'm writing the problem, I'll try to put the effort in and make that happen. So when we want to deal with these, we want to turn them back into the normal sum and difference formulas. So to do that, we're going to need a couple of things. The first thing that I usually do on these problems is I just write everything in terms of its reference angle. So I might change a sine of A into the negative sine of its reference angle or something like that. So we're going to do that. We'll write everything in terms of reference angles. So we're not going to change the functions at that point. We're just changing them in terms of their reference angles. Then we're just going to pick a trig formula. So like, do we want to end up with sine of x plus or minus y? We'll let the plus or minus be determined by the problem. But do we want to end up with a sine sum or difference, or do we want to end up with a cosine sum or difference? And then we're just going to make that happen. So to make that happen, we'll use cofunction identities. So that's our plan. So now I'm just going to do these two problems and show you my method of doing it, and then you can kind of adapt it on your own. So let's start with this problem. So the first thing I'm going to do is I'm actually just going to write down two kind of coordinate planes that are divided up into like pi over 9s and then in pi over 18s. So for example, for pi over 9s, we got 0 pi over 9 would be 0, 4.5 pi over 9 would be pi over 2, 9 pi over 9 would be pi, and then 13.5 pi over 9 would be 3 pi over 2. And then I guess 18 pi over 9 would be 2 pi. So the reason I'm doing that is to figure out what quadrant these kind of weird non-famous angles are going to terminate in. So for the first one, I look at it, it's 4 pi over 9. 4 pi over 9 is between 0 and 4.5 pi over 9, so I know that's in the first quadrant. So I will be able to just use sine of 4 pi over 9. Now I'm going to do the same thing with pi over 18, just kind of like set it up. So we got 0, we have 9, we have 18, and then we have 27, all pi over 9s. To get the bottom one, by the way, you just add the top one and the left one. So like to get 13.5, I did 4.5 plus 9 pi over 9, and that gave me 13.5 pi over 9. Okay, so I'm set up to do this. So the first one, sine of 4 pi over 9 is 4 pi over 9 is already in the first quadrant. So I don't need to do anything to that one. It already is written in terms of its reference angle. So let's look at 29 pi over 18. Okay, so that's going to be, I'm going to use the pi over 18 coordinate system that I set up. 29 falls between 27 and 36 pi over 18, so we're in the fourth quadrant. So I'm going to find the reference angle, so I'll do 2 pi, which is 36 pi over 18, minus 29 pi over 18, which gives me 7 pi over 18. And then I also need to know, is sign positive or negative in that quadrant? So I'm going to use this familiar ASTC, so only cosine is positive, cosine and secant, but only cosine is positive. So I'm going to replace sine of 29 pi over 18 with the negative of the sine of 7 pi over 18. So this is the key. We're going to write everything in terms of its reference angle. So now we need to deal with 19 pi over 18. So that's on our pi over 18 thing again. So it's between 18 pi over 18 and 27 pi over 18, so it's third quadrant. So I'm going to find the reference angle. So to do that, it's going to be 19 pi over 18 minus 18 pi over 18. So you subtract pi from the angle when you're in the third quadrant. And we just get pi over 18. In the third quadrant, only tangent is positive, so I'm going to replace sine of 19 pi over 18 with the negative of sine of pi over 18. And then we're going to do it one more time. So we got 17 pi over 9. So now we need to use our pi over 9 quadrant. So 17 is greater than 13.5. So we're in the fourth quadrant here. So I need to find the reference angle. So I will do 18 pi over 9 minus 17 pi over 9, which gives me just pi over 9. And in the fourth quadrant, cosine is the only positive, right? Because we have this. So I'm going to replace sine of 17 pi over 9 with the negative of sine of pi over 9. Okay, so that's our first step. And now what I'm going to do is I'm actually just going to rewrite this kind of like simplified. So you might actually choose to like flip the two products so that it starts with a positive, but I did not choose to do that. I think I'm going to do that in another example though. So all I'm doing here is simplifying a little bit, getting rid of all those extra parentheses and some negative signs. Okay, so we're here. Now what we need to do is decide like what type of formula do we want to end up with. So I'm going to say, I'm going to go with like sine, cosine, cosine, sine, right? So I'm going to turn it into a sine of either x plus or minus y. I don't know which yet, but I'm just going to do that. So to do that, I'm going to choose something and just change it, right? So I'm going to leave this because it's sine, cosine, cosine, sine. So I'm going to leave this one, and I'm just going to change this into a cosine. So to do that, I'm going to use a cofunction identity. So the sine of 7 pi over 18 is equal to the cosine of pi over 2 minus that. So pi over 2 is 9 pi over 18, and then minus 7 pi over 18, which is the cosine of 2 pi over 18, which is the cosine of pi over 9. Okay, so I can replace sine of 7 pi over 18 with cosine of pi over 9. What's really good about that is that if I look at the second product, I see a sine of pi over 9, and now I'm getting somewhere, right? Because now I have like sine, cosine of a thing, plus ultimately that'll have to be a cosine, I guess, and then sine of that thing. So I'm getting somewhere. So now what I need to do is I need to change this sine of pi over 18 into a cosine to like fit the formula. So I'm trying to get sine, cosine, cosine, sine. So I'm going to change this into a cosine. So the sine of pi over 18 is going to be the cosine of pi over 2, which is 9 pi over 18, minus pi over 18. And this is the cosine of 8 pi over 18, which is 4 pi over 9, which if you look at the product on the left is great because we have a sine of 4 pi over 9. So let's write this in. And we already know we're keeping the sine of pi over 9, and this 4 pi over 9 has shown up twice now, and that's really good because that's what we want. So we're done there, and we're keeping the sine of pi over 9. And now we're basically finished with this, so I'm going to rearrange it so it looks more familiar. So sine of pi over 9, cosine of 4 pi over 9, and then minus cosine of pi over 9, sine of 4 pi over 9. That's sine, cosine, minus cosine, sine, which is the sine of like a minus b, I guess. So pi over 9 minus 4 pi over 9, which is the sine of negative pi over 3. And the sine of negative pi over 3 is the negative of the sine of pi over 3, or however you want to think of it. It will ultimately be, it will be negative root 3 over 2. Okay, so what if at that stage where we started like just randomly choosing what to do, where we picked our trig function, what if we had chosen differently? Like I chose to do sine, cosine, cosine, sine. I didn't need to do that. So what I'm going to do is I'm going to copy a couple of essential things, and then I'm going to do it differently. So we got to this point somehow, and now what I'm going to do is I'm going to change it into cosine, cosine, minus sine, sine. So to do that, what I would want to do is first, I'm actually just going to rewrite it because I would like to have that negative sign in the middle. So I'm looking at this with something in the middle. So I'm thinking I'm going to make it cosine, cosine, minus sine, sine, which is like cosine of a plus b, and it'll work out for me. So to do that, I first need to change this thing into a cosine. So I'll use Cofunction Identity. So this is just to illustrate, like if you don't make a mistake, you pretty much can't go wrong. you will end up with different work, but the final result will be the same. That's kind of the key thing here. So here I've converted sine of pi over 18 into the cosine of 4 pi over 18, which is that right? No. It should be the sine of 4 pi over 9, right? Because it's 8 pi over 18, 4 pi over 9. That's whatever. I wrote it wrong, but I'm going to write it correctly up here. Okay, so 4 pi over 9. I need to change the sine of pi, which is good, right? Because we already have a sine of 4 pi over 9. So now let's change the sine of pi over 9 into a cosine. Hopefully I'll write this correctly. So it's cosine of pi over 2 minus that, but pi over 2 is going to be 9 pi over 18 minus 2 pi over 18, which ultimately gives me the cosine of 2 pi over 18, 7 pi over 18. So we have this, and let's replace that. So cosine. So this, I chose a different trig formula, but you can see it's like coming together because there's already a 7 pi over 18. So let's just write this. So if you write everything in terms of the reference angles, then you choose what trig function you want to, trig formula you want to use, and then you don't make any mistakes, it will work out. Your path might be different. So this is cosine of a plus b. Your path could be different, but you're going to end up with the same result, and that's what's important. So there's not one way to solve these. And so we get this, which is the cosine of 5 pi over 6, which again gives us negative radical 3 over 2. So we're getting the same final answer no matter how we do it. So I'm going to now do the other problem that I had written. If you think you've got it, you could just get out of this video. Otherwise, follow along. Okay, or you could try this on your own and then watch the rest. So I'm going to do the same thing, all reference angles. First, I'm going to set up two quadrants that are kind of, so I need pi over 15s and I need pi over 30s so that I can figure out what quadrant I'm in. I'd really just do this part for convenience because I know I'm going to need to do it eventually. And then I know I'm going to need to know what's positive where. Do it again. So this is for 30s. And obviously as you do this, you get a lot faster. I'm trying to explain every step as I go. You're just going to fly through making your decisions. Okay, so let's convert the first one. So cosine of 16 pi over 15. So I'm on my pi over 15s. That's a third quadrant angle. Get my reference angle. So 16 pi over 15 minus 15 pi over 15. It's just pi over 15. Cosine is negative in the third quadrant, so I'm going to replace this with the negative cosine of pi over 15. Let's do this for the second thing. So this, I need my pi over 15s again. 26 falls in the fourth quadrant. Find a reference angle. So we get this, 4 pi over 15. And cosine's positive in the fourth quadrant. So we're just going to replace cosine of 26 pi over 15 with cosine of 4 pi over 15. And then the last two actually, so we're in our over 30 quadrant system. 13 pi over 30 is in the first quadrant, so we don't need to do anything. And then the same thing is actually true for 7 pi over 30. It's also in the first quadrant. So for this, we're in the first quadrant, so we don't need to do anything. So this is pretty good. What I'm going to do here is I'm going to rewrite this so that negative's in the middle. I just feel like I would prefer that so I don't have to mess around with it. I make a lot of choices like that when I'm doing problems. I'm pretty confident I could do it the other way, but I like them to look exactly the way the formulas look, so I'll just rearrange as I can. Okay, so we have this. And now what I need to do is decide what formula I'm going to use. Well, I already have cosine, cosine minus, so I'm going to turn the second two things into sines, I think. So I will save these, just kind of preserve them. And I'm going to use cofunction identities to change the second two cosines into sines and hope that I get the correct angles, which I should if I didn't mess up when I made the problem. So I'm going to turn this into a sine. So cosine of pi over 15 is the same as or equal to sine of pi over 2, which I need to use 15 pi over 30 here so that I'm not messing around with decimals, minus 2 pi over 30, so 13 pi over 30, sine of 13 pi over 30. Which is going to be good because when I look at what I currently have, I already have a cosine of 13 pi over 30, just kind of sitting there, so that one's done. Now let's do the next one, cosine of 4 pi over 15, change that into sine. Hopefully I get the sine of 7 pi over 30 so that this works out. So we do the same exact thing. So I have this, which is sine of 7 pi over 30, which is good. That's what I was hoping for. Okay, so now I have cosine minus sine, which is cosine of a plus b. And that one worked out. So cosine of a plus b, so 13 pi over 30 plus 7 pi over 30, which is the cosine of 20 pi over 30, which is the cosine of 2 pi over 3. And the cosine of 2 pi over 3 we have memorized is negative 1/2. Okay. So what if at that stage where I had cosine minus cosine all reference angles, I had chosen a different formula, right? What if I had chosen to do sine minus cosine sine? So instead of making you like watch me do this, I'm just going to show the work that I did. I got down to this, right? I changed the first cosine into a sine, and then I changed the last cosine into a sine to get sine, cosine, sine. And then here I have sine, cosine, sine. So that's sine of a minus b, which would be the sine of pi over 15 minus 7 pi over 30, which is the sine of negative 5 pi over 30, which is the sine of negative pi over 6, which is negative 1/2. So again, it doesn't matter which way you approach it, you will get the same result. And that's two pretty good examples, I think. It all comes down to writing everything in terms of reference angles, choosing your sum or difference formula that you want to work with, and then converting using cofunction identities. All right, I hope you found this helpful, and good luck.